Remember the longest flight you've ever taken? Maybe it was a 12-hour long one, 16 hours, or even a straight 24 hours. Probably with or without a transit, if embarking to the US from a South Asian country. But have you ever heard of a flight that was in the air for more than 2 months? Yes, we were surprised too, because it was not a recent scenario. It happened almost over 100 years ago. From 1958 to 1959, 2 pilots set the record for the world's longest ever flight, when they flew non-stop for 64 days, 22 hours, and 19 minutes over Las Vegas. In total, the journey clocked 240,000 kilometers, about the same as flying around the Earth 6 times. And now, you must be thinking, how could an airplane fly non-stop for such a long time? Well, it was possible because of only one thing: in-air refueling. Now don't start doing mental math about how it happens, how a speedy airplane can take fuel at such a high altitude, because we're about to break it down for you. Back in November 1911, something small yet historically important happened over the city of Ansa during the Italo-Turkish War in Libya. An Italian pilot, Lieutenant Giulio Gavotti, dropped 4 grenades onto Ottoman military positions from his ETR-2 monoplane. The plane was flying at 600 feet altitude. Although those grenades didn't cause any casualties, it was the first instance of an aerial bombardment by a heavier-than-air aircraft. Just after 2 years, aerial bombing became a norm in warfare, and aircrafts were just going to be designed only for that purpose. But even under the best conditions, these early bombers could only stay in the air for about 3 to 4 hours maximum. This short flight time was a major drawback for using bombers in warfare, as it limited how far they could travel. Because of this, it was hard for these early planes to carry out bombing missions on far-off targets. At the same time, both military and civilian sectors were looking for a practical way to cover long distances. Often, those aircraft need to cross big bodies of water, so taking frequent stops for refueling or servicing was a big problem. Right after World War I, the aviation industry hit a bit of a slump because planes back then couldn't fly very far or carry much. So, people started losing interest in them. Even though engineers were more enthusiasts to go for a better engine and faster aircraft, the biggest snag to sustain the war was the limited range, and the only plausible solution was to find out how to refuel planes in mid-air. However, the idea was of paramount importance for military use, but it took nearly 30 years of trial and error before a practical system was finally out. The first attempts at air-to-air refueling were more like daredevil stunts. Those super risky tasks were done by the civilian pilots, who used to be also known as barnstormers. They would perform these at air shows. In these daring stunts, a crew member would climb out onto the wing of one plane while it's in the air. They'd then carry a can of fuel across the sky and transfer it to another plane to refuel it manually. Once the job was done, he'd have to make his way back to his own plane, all while both the planes were still flying. Pretty wild, right? But these wild adventures helped mankind take over the world. If we talk about the first in-flight refueling attempt that was done in a true systematic way, it was by Lieutenant Godfrey L. Cabot. On 3rd October 1920, he made the first real in-air refueling in Washington, D.C. Cabot used a Huff Dalland aircraft and a rope with a grappling hook to grab a 5-gallon can of gasoline while flying over the Potomac River. Although he only managed to get a small amount of fuel, this was the first time a plane extended its flight without landing to refuel. Cabot proposed this method to the Army Air Corps, suggesting it could be useful for transatlantic flights. However, the idea didn't gain traction and was soon abandoned. Even though Cabot's idea didn't get much groundswell of support at the time, it created a curiosity in other aviators. So they panned out their own risky methods for in-flight refueling, but all of these early attempts went in vain. After extensive research and calculations, 2 World War I pilots, Captain Lowell Smith and Lieutenant John Richter, figured out how to extend flight duration. In 1923, with permission from their base commander, Major H.H. Arnold, at Rockwell Field in San Diego, California, they attempted in-air refueling. Using Richter's engineering skills, they modified two Airco .4 billion dirhams biplanes to serve as test tankers. They fitted each plane with 50-foot hoses that could be lowered to refuel another plane flying nearby. On the 20th of April of the same year, Smith and Richter took to the skies for their first test flight. They managed to connect the tanker's hose to the receiving plane while both were flying, and they kept this connection going for over 40 minutes. However, no fuel was actually transferred during that flight, and by June 27th, they had upped their game and set a new flight endurance record. They stayed in the air for 6 hours and 37 minutes. Just 2 months later, they hit a major milestone by keeping a plane airborne for 37 hours. This was made possible by performing 9 mid-air refueling and transferring over 686 gallons of fuel. In October, Smith and Richter did something bigger. They took their air-to-air refueling system for a real-world spin. They flew non-stop from Sumas, Washington, to Tijuana, Mexico. It was a 12-hour journey, and they had refueling stops in Eugene, Oregon, and Sacramento, California along the way. This flight was more than just a demonstration. It showed that their refueling system could actually be used in real military missions. Despite the success of these tests, the dangers of air-to-air refueling would become apparent less than a month later during a crash at an airshow at Kellyfield, Texas, caused by a refueling hose tangling up in the propeller of the receiving aircraft. This event became the first ever fatality caused by mid-air refueling. As the 1920s progressed, aviation enthusiasts worldwide experimented with the technique in the pursuit of new aerial long-distance records. However, for the most part, air-to-air refueling was seen as a performing stunt by the aviation community. Even though the tests had shown a promising future, every great invention comes with some serious trouble, because less than a month later, a tragic accident happened at an airshow in Kellyfield, Texas. As the 1920s rolled on, people around the world were excitedly experimenting with air-to-air refueling. They were trying to set new records for long-distance flights. But for most of the aviation community, it still felt more like a daring stunt than a practical method. The next big step in air-to-air refueling came in 1929, when Captain Ira Eaker and Major Carl Spatz set out to break a flight endurance record. They aimed to cover up over 11,000 miles, which will probably need 151 hours of flying. Despite the US War Department's teensy hesitation, Eaker and Spatz led a team of Army Air Corps pilots using two Douglas C-1 aircraft as tankers and a Fokker C-2 tri-motor monoplane as the receiver. The tankers were upgraded with extra tanks, one holding 150 gallons of gas and another with 40 gallons of oil. They used the same refueling method that Smith and Richter had developed. The tankers lowered a 50-foot hose to the receiver plane, which had been fitted with a large funnel to fill up its fuel tank. On January 1st, the receiver plane took off from Van Nuys, California, for a critical endurance test. Major Spatz, standing on a platform on the plane, expertly caught the refueling hose from the tankers and guided it into a funnel. During the flight, they made 42 refueling connections, transferring nearly 5,000 gallons of gasoline and 245 gallons of oil. The flight ended early when one of the Fokker engines failed. Although the test showed that mid-air refueling was possible and could extend flight distances, the War Department didn't take much notice due to engine reliability issues. Despite some interest in long-distance flights, the US didn't focus on aerial refueling until after World War II. In the early 1930s, Sir Alan Cobham, a pioneer in long-distance flying and a World War I veteran, took on the challenge of aerial refueling in England. He used a modified airspeed Courier as the receiver plane and a Handley Page Type W10 as the tanker. By 1935, Cobham introduced a new refueling technique known as the grapple line looped hose method that showed a significant advancement in mid-air refueling. The receiver plane would drag a steel cable behind it. The tanker aircraft would shoot a line to catch this cable, pull it in, and attach it to a fuel hose. Once everything was connected, the receiver plane would reel in the hose. The tanker would then climb slightly higher, allowing gravity to let the fuel flow into the receiver plane. Cobham managed to pull off a non-stop flight from London to India by using this method. He relies on in-flight refueling to keep the journey going. By the late 1930s, Cobham's company, Flight Refueling Limited, became the first to produce a commercially viable aerial refueling system. Their looped hose design started being used in experimental tests to refuel large aircraft known as flying boats. When World War II broke out, these commercial trials were put on hold, and FRL shifted its focus to military applications for the Royal Air Force. In the final year of the war, FRL's refueling system was installed on Lancaster and Lincoln bombers in preparation for missions against Japan. However, the war ended before these systems could be put to the test in combat. When World War II ended, another tension began to rise: the Cold War. That's why US Air Force thought of focusing on aerial refueling seriously, because they need to carry out long-range missions. So, in March 1948, they kicked off the GEM program under the Air Materiel Command. The goal was to develop long-range strategic capabilities, which included figuring out how to refuel planes mid-air, adapting aircraft for extreme weather, and improving electronics. Strategic Air Command was put in charge of testing these new developments to see if they were practical for real-world use. Among all the projects, air-to-air refueling was given top priority. At the time, the only reliable system available was the grapple line loop hose system developed by Flight Refueling Limited. To get started, Air Materiel Command bought enough of FRL's equipment to convert 100 B-29S into receiving aircraft and 60 B-29S into tankers for the tests. The flight began and ended at Carswell Air Force Base in Fort Worth, Texas, with refueling stops near the Azores, Saudi Arabia, the Philippines, and Hawaii. The mission was a success, and people believed that aerial refueling could effectively give aircraft unlimited range. However, the flight wasn't without its downsides. One of the tankers crashed during a landing, tragically killing all 9 crew members on board. Despite the success of the journey, the Air Force quickly realized that the FRL system had its flaws. It was clunky, tough to operate, and relied on parts made overseas, which wasn't ideal for widespread US. So the US Air Force started finding a better option, and they did so. The Strategic Air Command General Curtis LeMay asked Boeing to come up with a refueling system that could transfer fuel faster than what was available at the time. At the same time, the flying boom refueling concept was born. The concept was first introduced in 1948 by German scientist Bob Holman, who was working with Materiel Air Command. However, the system moved from concept to operational testing in under 2 years. The flying boom refueling system uses a rigid pipe attached to the back of a tanker aircraft. This pipe moves with the receiver plane thanks to its flexible mount. At the end of the pipe is a nozzle connected by a ball joint, which fits into the fuel tank of the receiving aircraft. A special valve inside the nozzle keeps the fuel from flowing until everything is properly connected. The boom is effective because it can be controlled by an operator. The operator uses small hydraulic wings on the boom to steer the nozzle into the right position. The boom can also extend or retract to reach the receiver plane. During refueling, the receiver aircraft flies behind the tanker, guided by lights or radio signals from the boom operator. Once they're aligned, the operator extends the boom to connect with the receiver, and the fuel flows through the boom. On September 16, 1948, a B-29 was modified for the first flight to test the flying boom system. The results were impressive. This new system was much more stable and allowed refueling to happen at higher speeds without a hitch. It was also better at handling rough weather and could even resist lightning strikes. One of the biggest advantages was its efficiency. The flying boom could transfer up to 500 gallons of fuel per minute, whereas the old FRL system could transfer 100 gallons per minute with. The flying boom system worked so well that shortly after the successful first flight, everyone decided to stop using the FRL system. From then on, the flying boom became the standard for Strategic Air Command, and all future bombers were equipped with this new refueling system. Between 1950 and 1951, Boeing converted 116 B-29S into KB-29 flying boom tankers, so they can have a way for more efficient mid-air refueling. At the same time, they introduced the KC-97 Stratofreighter, the world's first production aerial tanker. While the KC-97 got the job done, it wasn't without its flaws. Its piston engines used gasoline, while jet-powered planes needed kerosene-based fuel. Plus, the KC-97's slower speed meant that jet aircraft had to slow down to a point where they were almost stalling just to refuel. To solve these problems, Boeing developed the KC-135 Stratotanker, a high-altitude, high-speed, jet-powered aerial tanker that could keep up with the faster jets and handle the different fuel needs. To make the KC-135, Boeing took its 367-80 airframe. About 730 of these planes were built for and put into service over the next decade. The new tanker could carry up to 30,000 gallons of fuel, which it could either use or transfer to other aircraft mid-air. For speedy aircraft, the KC-135 was a good match because it was able to refuel planes flying at speeds between 180 and 350 knots. It means the tanker was suitable for just about every aircraft in the Air Force. On top of that, it could haul up to 80,000 pounds of cargo or carry as many as 250 passengers when needed. Since its first flight on July 15, 1954, the KC-135 has proven to be one of the most reliable military aircraft, remaining in service for over 50 years. Its modern versions can pump fuel at a rate of up to 1,000 gallons per minute, which is super important to the US Air Force's refueling operations. In 1950, a World War II fighter ace started testing the first probe and drogue refueling system. His name was Colonel Dave Schilling. Since this system was designed specifically for fighters, Schilling worked on refining it and proved it could work with multiple aircraft at the same time. This setup had a big advantage over the flying boom system. By 1952, the US Air Force wanted to see how well the probe and drogue system worked in real combat, so they put it to the test in Korea. They equipped F-84E fighter jets with probes and KB-29 tankers with drogues on their wingtips and tails. The new system allowed the F-84E to set a new endurance record of 14 hours and 15 minutes over 5 combat missions without needing to land. By the 1960s, aerial refueling had become a standard operation, and the probe and drogue system had really taken off globally because it was so adaptable. One cool innovation from this time was the buddy pod, a hardpoint pod that was basically a self-contained hose drum unit. This allowed different kinds of aircraft, even other fighters, to act as tankers. They also developed adapter units that let you convert the ends of flying boom refueling pipes into drogues, so tankers using different systems could work together. The probe and drogue system proved to be so useful that it became the standard for NATO, the US Navy, Marines, and even some Army aircraft. This meant that drogue-equipped tankers could refuel probe-equipped planes from other countries. The Soviet Union even took a page from this book, reverse engineering and adopting the NATO system so their tankers could work with NATO aircraft too. Over the last 50 years, aerial refueling has become a regular part of military operations, essential for planning missions. Technically, the systems used for this haven't changed much since the 1950s because they're so reliable and effective. But recently, things are starting to get more futuristic. On June 4th, 2021, the US Navy made history by performing its first ever aerial refueling between a manned aircraft and an unmanned tanker. They used a Boeing MQ-25 Stingray and a Navy F-18 Super Hornet for this test. It took place over Mascouta, Illinois, and lasted about 4.5 hours. During the flight, they managed 10 minutes of contact, transferring around 50 gallons of fuel. This MQ-25 program is a step toward a future where carrier-based fleets might rely heavily on unmanned systems. If things keep moving in this direction, By around 2025, a significant portion of the Super Hornet's flight hours could be spent on refueling missions. This shift could eventually change the way refueling is planned, potentially making older manned tankers less common. So, if we end talking about aerial refueling, take a look back from where we were and where we are now. It's just amazing to see how far we've come. What started with risky and hands-on methods has turned into a high-tech operation that's important for military missions today. Now, the recent trials with unmanned tankers, like the MQ-25 Stingray, show just how much potential there is for further innovation, and how the in-air refueling is a lifesaver.